Good day guys, how are you doing? This is Shahata from KBD, and today I'm going to show you how to design this Geneva drive mechanism and animate it in Fusion 360. Coming at you right after the break. Hi guys, the content in this channel is sponsored by my courses in Udemy. You can get these courses for $10 each if you follow the links in the description. Take a look at it, you might actually like it. Alright guys, let's get into it. So the first thing I would like to do is I would like to make the backbone sketch, or rather the skeleton sketch, from which we are going to kind of like extrude and make all the components in the mechanism. I would do this in the top plane. So what I would like to start with, I know the mechanism is complicated, but we can dissect it into very simple components and we can build our way from there. So let's make a circle at the center. This circle is going to be the backbone of the driven wheel. Let's give it a reasonable size. 50 millimeter in diameter will do. This size will depend on how many dwells and how many slots the wheel will have, but for what I have in mind, 50 is going to be enough. Now again, let's just guesstimate how the rest would look. So I am going to make some sort of another circle. Let's make it 20 millimeters. This circle is again going to be the backbone of the next part of the mechanism, which is going to be the drive wheel. Now let's turn our attention to the driven wheel here. The driven wheel will have slots, and these slots will determine how many stops, or rather how many dwells, the driven wheel is going to make. Now we have to decide how many dwells we want to have, because based on that we are going to decide how many slots we are going to model. So I'm going with 6. 6 is going to be okay. You can do more. I think the maximum, the biggest driven wheel is around 18 dwells per one revolution. So think about it very, very reasonably. If you have 6 dwells, that means you have 6 slots. Now, if you have 6 slots on the wheel, that means that the angle between each two slots is 60 degrees. Let's do that. So the first thing, I'd like to draw the center line of the slots. So there's one line here that's going to be vertical. Again, there will be one slot here. I'm turning this into a construction line. And let's draw another line going somewhere there. Again, this line is also going to be construction. Now these two lines represent the center lines of two slots that are going to be next to each other. We just said that because we have 6 dwells, this angle between these two centers is going to be 60, exactly like I did here. It's going to be 60. Okay, that's good. Now let's turn our attention a little bit to the drive wheel. The drive wheel has some sort of a locking ring that's going to be cut out of this circle, and it's also going to carry the drive pin. Now the drive pin is going to be somewhere on the center of the slot by definition, because it's going to kind of like slide inside the slot. So let's put it somewhere here. 3 millimeter in diameter will do, so that's nice. Okay, now this drive pin has to be connected to the drive wheel somehow. So let's do that now. Simply just let's drag a line from this circle to this circle. Now let's make sure these lines are tangent. Yeah, okay. Let's make another line from here, from somewhere on this circle. Yeah, somewhere there, doesn't matter where. Let's make sure this line is also tangent here and tangent here as well. Okay, now the way this is going to work, the drive wheel, like you saw in the animation, the drive wheel is going to rotate. Now when the drive wheel rotates, this pin is going to slide inside the slot and then somehow rotate and then go out from this slot, right? From this place where this slot is going to be, because the rotation is only 60 degrees. That means that the circle at which this pin is going to revolve has to be tangent to this line, which is going to be the center line of the slot, and this line is going to be the center line of the exit slot, or the exit location of the next slot. If that doesn't make any sense, when we do the motion, you will see what I mean. But for now, let's make a circle that's going to touch on the point where this pin is. Let's turn this circle into construction. Now this circle has to be tangent to this line. Select them, right-click, tangent. And it also has to be tangent to this line. Select them, right-click, and make them tangent. Now you can see everything now is fully defined, aside from this line, as probably it's not tangent here. Select them, right-click, and make them tangent, and that's it. Now everything is in black, and everything is fully defined. Now, at this point, we already laid out the major components of our mechanism, and we are almost done. Now let's just do some touch-ups. First of all, let's draw actually the slot itself. So let's go to Sketch, make a slot. It's a centerless slot. Slot is extending from here to somewhere there. I think 15 millimeters is going to be enough. The diameter of the pin is 3 millimeters, so I'm sticking up a little bit up from 3, so 3.1 in diameter, 3.1 millimeter in diameter will do. And let's decide on the length of the slot as well. The length of the slots need to be only sufficient, so 15 for now will do. Now what I would like to do is have some kind of a cutout. This cutout is going to be somewhere here on the drive wheel, and this cutout will allow the driven wheel to rotate. You'll see what I mean when we finish this, but just keep what I said in mind. To do this, I'm going to do a point. This point is going to be on the other side of the mechanism. Now this point and this point need to be symmetrical around the center line we just made. Select them, select the center line, right click, make them symmetrical. Now I'm going to sketch an arc, a center point arc. This arc is going to start here, and it's going to, I don't know, somewhere here on the drive ring, right? Now the diameter of this arc has to be slightly more than 50. That means that the radius has to be slightly more than 25. I'm going to make it 26, and I know it will work. Okay, so far so good. Now the only thing left for me to do now is to make a pattern of the slot and also the drive ring here because of the cutout. So let's do that. You just go to Sketch, Circular Pattern, select this circle, and now let's select the slot. This line, this arc. Make sure you select the rest of the slot, not this line, not the circle. Now the center line, the center point is this point, and we are going to have 6 in the quantity, and you can see that the second slot, or rather the last slot anyway, this slot is exactly laying where we said it was going to be. So you can see now that the drive pin is going to go here tangentially and going to exit also tangentially around following this circle, which is perfect. Click OK. This is it. The last thing we need to do with the sketch is add some kind of wheels or some kinds of shafts. So I'm giving this 7 millimeter in diameter. I'm doing another one here at 4 millimeter in diameter. Okay, now it's time to extrusion and make components and everything. So press E from your keyboard. Now I'm going to extrude the driven wheel first. So let's select this profile and this profile as well. And this is going to be a new component. And this new component is going to go up. I would say 3 millimeters is actually fine. Yeah, okay, good. I like to turn on the color cycling toggle. It's better. It's like good for my eyes, I would say. Now I'd like to extend this shaft. So again, E from the keyboard, select this profile and extend it down 15 millimeter or whatever. Now we need to model, or rather extrude, the drive wheel. To do this, let's hide this component we just made. To make sure that we select the right profiles, select the base profile for everything that's going to be included in the drive wheel. So this includes everything here and this small part as well. Now this is going to be kind of like the ground of the drive wheel, so extrude it down just 1 millimeter. Make sure it's also a new component and press OK. Now let's extrude the rest of the body of the drive wheel. Actually, we can just go ahead and extrude the shaft for the drive wheel as well first. So this is going to be negative 15 millimeter, and it's going to be a joint operation. Notice how I'm extruding down from this view. Okay, the last thing is to extrude this profile, which is going to be the profile for the lock ring on the drive wheel, yeah, and also the drive pin here. Extrude them up to 3 millimeter. This is a joint operation, and press OK. Go to the top, go to the home, and actually this is it. Lastly, okay, let's hide the sketch and look at what we have here. Now everything looks good, but we need some kind of a reference frame from which these things are going to be attached. To do that, I'm going to model something that will kind of like replace what a frame for this mechanism would look like. So S from your keyboard, let's make a new component. This component is going to be called frame. And S again from the keyboard, we're going to sketch, and we're sketching somewhere here, backside of the drive wheel. The first thing I would do is actually project these two circles, this circle of this shaft and this shaft. With that, I can click escape, and now let's do some kind of a representation of what the frame would look like. So from the sketch menu, let's go to the polygon. I would like to use circumscribe polygon, and this is around the maybe, I don't know, 3.5 millimeter in diameter would do. And again, right click up, and again let's do it here, 5 millimeters, and this is actually enough. E from the keyboard, and let's extrude these two profiles somewhere up here. And this is a new body because we're already inside the component. Pressing OK to end the dialog. Hide the sketch, and this is actually it. Now let's go back up, activate this, go to home. Let's rename the components. I don't like to leave things this way. So this is a driven wheel, and this is the drive wheel. Now, the last thing I would like to do is just to make the joints and ensure the animation works. So let's kind of like ground our frame component and Shift J from the keyboard to make the connection as built joint. So we are going to connect the drive wheel with the frame, and it's going to be a revolute connection, and the location is going to be here, rotating very well. Again, let's do the same thing. Shift J from the keyboard, driven wheel, frame. There's going to be a revolute connection somewhere there. Again, looking very well. Now, the last thing I'd like to do is activate the contact between this this component and this component. So when the drive wheel rotates, it's actually going to affect and rotate the driven wheel. To do this, let's go to Assemble. Let's go to Enable Contact Set. Right-click, create a new contact set between this component and this component. Pressing OK. Actually, this is it. Our job is done. Let's go to the top view. Now, if you right-click this joint, click on Animate Model, look at this. Now, this is what I was talking about. It's entering tangentially and again exiting tangentially. Again, entering the slot tangentially and exiting tangentially, entering tangentially and exiting tangentially. And this is it, guys. I just hope you've liked the tutorials. I tried to be concise. And if you have any feedback on my way of teaching, please let me know in the comments below. Now, if you like this video, like it. If you dislike this video, disliked it. If you have different feelings about the video, you can please leave me a comment in the description below. And if you like to see more tutorials and more things related to mechanism design, just hit that subscribe button. See you guys later. Bye.